Now let's try doing the same types of problems but using the p-value method instead of the critical value method. So the process is mostly going to be the same. The difference is we won't need to find critical values, and instead we'll find the p-value that goes with our test statistic, and we'll compare the p-value to our significance level, our alpha. And if our p-value is smaller than alpha, our cutoff, that means that we'll reject the null. That means that the probability of getting our sample is just too small, that we don't think the null hypothesis can be true. And so if our p-value is less than alpha, we reject the null, and otherwise we'll fail to reject the null. So let's look at this next problem. It says a sporting goods store believes that the average age of its customers is 38 or less. And they look at a random sample of 40 customers, and in the sample, the average customer age was found to be 41.2. And it says to assume that the standard deviation for customer age is 9.0 years, and we're using an alpha, a significance level of 0.01. And the question is, does the sample provide enough evidence to refute the age claim made by the sporting goods store? So let's see. The question is, do we have enough evidence to refute their claim? So that means that their claim should be the null hypothesis, and we want to see if we have enough evidence to reject it. So these are both going to be about the mean. And their claim is that the average age is 38 or less, so that our mean is less than or equal to 38. And so the alternative is that the mean is bigger than 38. And this makes sense because in our sample mean was bigger than 38. And so we want to see if we have enough evidence to conclude that the alternative is true. So here's our setup. We have our statements. Now let's draw our curve. And if we look at our alternative hypothesis, we're looking to the right of 38, so this is a right tail test. So our rejection region is going to be a right tail, and we know that the area of it is 0.01. So with the critical value method, this is where we would now find our critical value, but here we are going to skip that step because we're using the p-value method. So we have our rejection region. Let's find our test statistic, and we're going to use our test statistic to find our p-value. So our test statistic is going to be x bar, which is 41.2, and then we'll subtract the mu from the null hypothesis, which is 38, and then in the denominator we'll have sigma, which is 9.0, divided by the square root of n, which is 40. And so we'll switch to Excel and see what this test statistic is. And for the p-value, we're going to want to find the area to the right of that test statistic, since we're doing a right tail test. So our p-value, since it's an area to the right, we'll do 1 minus norm.s.dist of whatever our test statistic is once we have that in Excel and true. So let's switch to Excel and see how to do this. So our n is 40. I'm going to put in all the things that we know. Our x bar is 41.2. Our sigma, our standard deviation, is 9.0. And let's see, we're using an alpha of 0.01. And our statements, you could type these in more formally. I'm just going to type these. Our null is that the mu is less than or equal to. And if I'm not finding the equation formula in Excel, you can just type less than equals, and I'll know that that means less than or equal to 38. And the alternative is that mu is bigger than 38. And so let's see, we said our test statistic. In the numerator, we would have our x bar, 41.2, minus 38. And in the denominator, we would have sigma divided by the square root of 40. All the numerator is in parentheses, and all the denominator is in parentheses. So our test statistic is about 2.249-ish. And so our p-value is going to be the area to the right of that test statistic, which is 1 minus norm.s.dist. And then I would click on this value and put true. And remember, don't type in an approximation of the test statistic. Actually click on the value in Excel so that we're not rounding until the end. Okay, so our p-value is about 0.01. And we want to compare that to our alpha. So we want to see if our p-value is bigger or smaller than alpha. And it looks like that p-value is a little bit bigger than alpha. It's a little bit bigger than just 0.01. So this is bigger than our alpha. And when our p-value is bigger than or equal to alpha, that means that we fail to reject the null hypothesis. That means that our test statistic is not in the rejection region. And so here we would not have enough evidence. We would not have enough evidence to conclude that the mean, the average age of customers is less, or is, more than 38. We don't have enough evidence to conclude that the mean is more than 38, and so we can't refute the claim that they made.